Good morning. We are members of the Arizona State University Concrete Canoe team. My name is Rene Bermudez, and I am this year's project manager. And this is Jose Rodriguez, the team's mix design engineer. We represent a total of 8 lead engineers and a task force of 25 student members. Throughout the course of the project, hard work, a strict critical path, and efficient communication skills resulted in a successful concrete canoe. I would like to present Breastroke. Today, we would like to highlight the 3 major innovations, which are a stabilizing strake, carbon fibers in our mix, and aesthetic perforations. Breastroke is the result of the design of Passion, a 5-foot prototype design, and Practice Canoe, a full-scale model. From the Practice Canoe to Breastroke, important changes were made in order to improve performance. While the overall length and beam stayed the same, other features were modified, such as the front rocker and the type of chines. The most important innovation made was the addition of a strake. The strake enabled the hull to increase its stability while at the same time being able to decrease its entrance angle, allowing for a faster canoe. At the same time, a CFD analysis was performed on Breastroke in order to calculate the results of a narrower entrance angle. Going from 11 degrees to a 4-degree entrance angle, we were able to reduce the drag coefficient by 15%.
For the structural analysis, Breastroke was modeled with a 9/16 of an inch thickness. 4 load cases were considered, which included transportation and different race configurations. The most critical case was the 3-man ridge, which resulted in the higher stresses and deflections. The main goals for the mix design were to provide a concrete that would be buoyant, it would meet the strain requirements found by the structural analysis, and it would be aesthetically pleasant. To begin, increasing the particle size decreases the surface area that needs to be covered by the cement paste. This in part reduces water demand, yielding a lower water-to-cement ratio of 0.3, ultimately increasing strength. The inner layer of Breastroke was a concrete containing glass fibers for aesthetic purposes. The next 2 concrete layers contain cardboard fibers, which deliver the higher tensile strength and ductility. After continuous communication with the construction team, it was suggested that a finishing mix be developed in order to cover the appearance of the darker mix and create a better surface for sanding. The primary cementitious materials used in Breastroke were white cement and metakaolin because they create a creamier color paste. The primary aggregates chosen were macrolide for its availability and forever glass spheres for their appearance. Extender spheres and glass bubbles were also used as a light, finer aggregate. The mixes developed satisfy the set goals and provided reliable material for the construction of Breastroke.
During the early stages of the project, team leaders decided it was necessary to construct 3 canoes using the same method in order to increase our experience level. During the construction of Passion, a new method for measuring thickness was developed, which was the first improvement implemented in the construction of the Practice Canoe. For Practice Canoe, the EPS used in Passion was replaced with polyurethane foam. This material exhibited better mold working properties such as sanding and cutting. A CNC machine was used to cut all 116 pieces. During the construction stage of this canoe, quality control engineers compiled a list of improvements which were crucial for the construction of Breastroke. After cutting and assembling 2 molds, the construction team had gained a new level of expertise. This was reflected during the cutting process of Breastroke, which was decreased from 2 weeks to 12 hours. For this mold, EPS was placed at the bulkhead locations because of its light weight, and polyurethane foam was kept in the main body of the mold. The carbon fiber grid was pre-placed on the mold with spacers, which facilitated the measurement of the first concrete thickness. An innovative approach that ASU came up with this year was to include aesthetic perforations on the walls of Breastroke. In order for this to be accomplished, every aspect from hull design to mix design to construction had to be coordinated. Special aluminum reinforcements were designed and machined to be placed in a concentric location where the perforations would be gradually drilled to 1/2 inch. As a result of the experience gained from the construction of 2 canoes, Breastroke was cast in an impressive 3.5 hours, superseding any casting time from previous years. Breastroke was cured for 26 days, and after the sanding process was complete, the canoe was stained and finally sealed. As we have shown today, Breastroke has 3 major innovations: the strake and hull design, carbon fibers in our mix design, and aesthetic perforations. These innovations combine to make Breastroke an outstanding concrete canoe. We would now like to address any questions regarding the design and construction of Breastroke.